Okay, so in this section we're going to talk about rates of change and tangent lines to curves. So to understand about this, let's start with the secant line versus tangent line. Let's assume that there is a function of fx and this is a curve for the function. This function represents some population, for example, and x represents time. So to understand about the secant line versus tangent line, let's pick 2 points x1 y1 and x2 y2 and draw a line L1 through these 2 points. And let's pick just one point x3 y3 and then draw a line L2 through that point. Then in this example, this line L1 is called secant line and this line L2 is called tangent line to the curve. Okay, so difference, you can see that secant line passes through 2 points but the tangent line only touches to the curve. Okay, so now, because as you can see here, secant line is passing through the 2 points, finding the slope of the secant line is easy by using the formula. Okay, if you know 2 points on the on 2 points on a line x1 y1 and x2 y2, these are just the 2 points. The slope, let's say m represents slope of this line, can be found by using this formula, which is on the top, difference between the y coordinate over the difference between the x coordinate. So we can use the same idea to find the slope of this secant line L1. The slope can be found by using the very same formula for the secant line. But in case of the tangent line, we have to use this idea of we have to use this formula of the slope of the secant line for finding the slope of the tangent line. And for that, we have to understand the meaning of this. So look at here, let's say this is a graph. Okay, and I would like to find out the slope of the tangent line at this point, let's say xy at this point. So this is the line, let's say t1, and t1 is the tangent line at point xy, or maybe x1 y1, for example. I would like to find out, or maybe x3 y3, whatever points, that's okay. I would like to find out the slope of this tangent line t1 at point x1 y1. And since we know how to find the slope of a line if we have 2 points, but in this case we just have 1 point, so what we can do is, look at here, what we can do is, I'm just going to take another point here. Let's say I'm just going to take x2 y2 and then I'm just going to join these 2 points. You see here, so now I know the slope of line t2 because of these 2 points. By using this formula, I can find out the slope of the line t2, which is secant line. Now the idea is, whenever this points gets closer to this point x1 y1, so meaning is when x2 gets very close to x1, when this the value of x2 is very close to x1, so if I just take this x2 y2 instead of taking far here, if I take this x2 very close to x1, now I can use the very same formula of slope of a secant line to find the slope, to approximate the slope of the tangent line at t1 at x1 y1, slope of the tangent line t1 at x1 y1. So now look at here, when x2 gets very close to x1, this slope which is m would be, this m, which is y2 minus y1 over x2 minus x1, represents slope of this tangent line t1. When x2 approaches to x1, when x2 is very close to x1, the slope of the secant line becomes the slope of the tangent line t1. Okay, we can write it down this thing very in another way as well. So let me just use one blank page here. So in the coordinate system, let's say this is the graph of a curve, and I would like to find out slope of the tangent line here, tangent line T1 at x1 y1. And now for that I'm going to take another points very close to x1 y1. So let's say this is x1 y1. So that means on the x coordinate, on the x-axis, x1 is the point on the x-axis, and I'm going to take another very close point, which is, let's say, x1 plus h. H means the difference from x1. So that is very close to, this point is very close to x1, meaning the value of h is very close to 0. If I do that, I would be able to join these 2 points and find out the secant line. And now I know the slope of the secant line. I know the point, this point is x1 plus h, comma, the value of y value at x1 plus h. So if this is function f of x, then the y value would be the value of the function at x1 plus h. So I can find out the slope of the tangent line, slope of the tangent line T1 at x1 y1. I can find out by taking this h very close to 0, which I can write limit when h approaches to 0. The slope of this line, let's say this T2, the slope of the line T2 becomes the slope of the line, slope of T1 at x1 y1, if I take h very close to 0. So how do I write it? The slope of the line T2 is actually the y value, the difference between the y value over the difference between the x value. As you can see that the difference between the x value between these 2 points is x1 and x1 plus h. As you can see that the difference is h. So I can write h here. Okay, so this helps us to find the slope of the tangent line. So instead of x1 y1, you can write it down as a x comma y. So you can replace this as the value of the function at x plus h minus f of x over h when you take h approach to 0. This represents slope of the tangent line at x1 y1. Okay. So let's say f of t measures the distance traveled at time t. Be specific. There is some object which is traveling, and we can model the distance of that object by using a function f of t, where t is the time. Then we can find out the average speed of that object by using this formula, which is basically slope of a secant line. So there is an object which is moving here. Let's say this is f of t, and we want to find out the average speed between average speed over t1 to t2. That means, let's say there is a time t1 and there is a time t2. We can find out the 2 points on this curve. So average speed over this interval is actually slope of the secant line here. Okay, this is the formula for the average speed. And if you want to find out the average rate of change of any function, we can do the very same thing. Let's say a function y equal f of x, and we would like to find out the average rate of change of this function over this interval x1 and comma x2. Then this is just del y means change in the value of y over the del x means the change in the value of x, which is basically the value of the y value, which is x2 at x2 minus y value at x1. So this is y2 minus y1 over x2 minus x1. So basically you can find out the average rate of change of any function. If you would like to find out the rate of change, average rate of change of any function f of x, then you can use this formula. So that gives you the average rate of change. But if you are interested to find the rate of change of a function at one specific point, that is actually the slope of the tangent line. This is your slope of secant line, slope of a secant line. And if you would like to find out the rate of change of function at some specific point, you want to find out the slope of the tangent line. Okay, so that's why we discuss about this slope of the secant line versus slope of the tangent line. And what is that? How do you do that? There is a formula, this one. This is the formula we derive. This represents slope of the tangent line at any point, any specific point. This is slope of the tangent line at x1 comma fx1, which is y1. So this is slope of a secant line if you are trying to find out the average rate of change over this interval. Okay, and this represents the slope of the tangent line. So I would just based on your preference, if you are trying to find out the average rate of change, then this is what you are going to use formula. If you are trying to find out the slope of the tangent line, then this is the formula you can use. Let's see one example. Find the average rate of change of the function. This is the function and this is the interval we have given. So we can find out this by finding, so let's say this is your function and we want to find out the average rate of change from 4 to 6. So we already have x coordinate, we need to find out the y coordinate by using this function. So the y coordinate at 4 is the value of the function at 4. Just plug x equal to 4 here. 9 times 4 cubed plus 9. If you do this math, then that would be just use a calculator, and I'm going to do the same thing here. So that is so that is 585. So this is 585. I can also find the value of the function at 6, which is which is 1953. By just replace x by 6 and you will be able to find out this. So the y coordinate at 4 is 585. The y coordinate at 6 is 1953. Now if you want to find out the average rate of change, you can use this formula, this one. This is average rate of change, and that formula is average rate of change. Average rate of change can be found by using this formula, y2 minus y1 over x2 minus x1. y2 means this value, which is 1953, minus y1 is 585 over 6 minus 4. So if I subtract and divide it by 6 minus 4, which is 2, divide by 2, that is 684. So the average rate of change of this function on this interval, that's average rate of change. That's average rate of change on the interval is 684. Okay. The next question is find the slope of the curve. So we have given a function and we have given a point and the equation of tangent line. So we need to find out the slope of the function, slope of the curve. Slope means it's a rate of change. So there is a curve. Let's say this is the curve. We want to find out the rate of change of this curve. And we can find that by finding the slope of the tangent line at that point. So if you are interested to find the rate of change of any function at one particular point, you need to find out the slope of the tangent line at that particular point. So here in this case, the point is, let's say at P, let's say 3 comma 76. I'm just randomly drawing this curve, so make sure that this is not exact curve for this function. This should be parabola. So I might just draw parabola here. So the curve should look like this. So at 3, the value of the function is 76, and you can find that thing, it's the value of the function when x is 3, but that's already given here, so you don't have to do that, but I'm just trying to explain you. So now if you would like to find out the slope of the tangent line at this point, you can go back here and use this second formula. Okay, so slope of the tangent line, let's say m represents the slope of the tangent line at this point P, then that is, you can use h, so the value of the function at 3 plus h minus the value of the function at 3 over h, and when limit s goes to 0. So that's the formula we can use. Look at here, the value of the function at x1 plus h, in our case x1 is 3, so 3 plus h minus the value of the function at 3 divided by h, and find out, for finding the slope of the tangent line. Oh yeah, so I have to make sure that, and this is actually the slope of the secant line, but this becomes slope of the tangent line when you take h approach to 0. That was what I was explaining here. When h approach to 0, this slope of the secant line becomes slope of the tangent line. So this becomes slope of the tangent line when h approach to 0. So you use the very same expression, but you need to take the limit when h approach to 0. So just plug the value here. So find out the value of the function, replace this x by 3 plus h. So f 3 plus h is equal to 8 times 3 plus h squared plus 4, and just use what is 3 plus h squared, just use the formula, that is 9 plus 6h plus h squared. Just multiply 3 plus h times 3 plus h, that will give you 9 plus 6h plus h squared. And if you simplify this, it will be 8 times 9 is 72, 8 times 6 is 48, and this is 8h squared plus 4. So this is the value we're going to use for the first expression, which is 72 plus 48h plus 8h squared plus 4 minus f of 3, we already calculated that, which is 76. So as you can see that 72 plus 4 is 76, so we are just going to cancel this thing. Now for finding the limit of this expression, first of all simplify this expression. So on the top, if you factor out h, that will be 48 plus 8 times h over h. You can just cancel out that, and now find out the limit of this expression. For finding the limit, just take h approach to 0, so second part would be 0, so finally you get 48 only. So the slope of the tangent line on this curve at this point is 48. Okay, so that's the slope. We're not done here, we also have to find out the equation of the tangent line. So let me just insert one page here. So if there is a line, and if you know slope of that line and at least one point on that line, then there is a formula for find the equation, which is y minus y1 is equal to m times x minus x1. So in our case, if you look at here, go back here, you have a point 3 comma 76, you have a slope 48. So our x1 y1 is, it's a 3 comma 76, and then slope is 48. So if you use this formula here, that would be y minus 76 equal 48 times x minus 3. Now just simplify this. I can just add 76 both sides, meaning I'm just bringing this 76 to the right side and just distributing this 48 here. So 48x minus 3 times 48, which is 144. And if you add this 76 both sides, there will be 76 here. So that is 48x minus, just subtract 76 from 144. So that will be 68. 144 minus 76 is 68. So the equation of a tangent line is y equal 48x minus 68. So this is the equation of tangent line. Okay, that's how we can find slope of a tangent line and equation of tangent line. The one thing you have to keep in mind from this section is you can use this formula, the slope formula for a secant line, to find the slope of a tangent line by taking these points very close to each other, and that's where you have to use this limit approach. So in this example, as you can see, when h approaches to 0, this slope of the secant line becomes the slope of the tangent line. So this is the formula for secant line, and it becomes the formula for the tangent line when h approaches to 0. So that's the one thing you have to understand. Okay.